Good afternoon, class. We are looking at section 3.1, derivatives and rates of change. And here's part 2. We are going to continue looking at more examples. Derivatives and rates of change. The distance in feet of an object from a starting point is given by s of t equals 2t squared minus 5t plus 4d, where t is time in seconds. What is the average velocity of the object from 2 to 4 seconds? Even if they don't mention the word average, it means average because 2 points in time is given. So basically, V of average is S of t sub 2 minus S of t sub 1 over t sub 2 minus t sub 1. So S of 4 minus S of 2 over 4 minus 2. We are going to plug in 4 into this function. So we get 2 times 4 squared minus 5 times 4 plus 4d minus, then we're going to put 2 times 2 squared minus 5 times 2 plus 4d, and the denominator is 4 minus 2 or 2 simply, so it's really not a big deal. And so with that being the case, we end up with the following. Now, let's quickly simplify the numerator. This is 16, so this gives us 32 minus 20 plus 40, which ends up being 52. This is 4, so 2 times that, 8 minus 10 plus 40, which ends up being 38. So 52 minus 38 is 14 over 2. The answer is 7. Units of the numerator in feet over the units of the denominator in time in seconds. So 7 feet per second. What is the instantaneous velocity of the object at 4 seconds? Now, we are given 1 point in time, even if they don't mention instantaneous, that's what it means. So we are going to use the instantaneous velocity, and that is the limit of s of a plus h minus s of a over h as h approaches 0. A is 4. Now we're going to plug in and evaluate. So the limit as h approaches 0, the denominator is h. We want to find this one. So 2 times 4 plus h squared minus 4 times 4 plus h plus 4d minus s of 4. Now, I can plug in and evaluate it. Or remember, s of 4, we have 52 here. So we can leave it as 52. Four plus h squared, again reminding you that if you want to square a plus b, you get a squared plus 2ab plus b squared. If we happen to have a negative sign here, gives rise to negative sign here. Therefore, 4 squared is 16 plus 2 times 4 times 8, h is 8h plus h squared. Now 2 times that, 32 plus 16h plus 2h squared minus 20 minus 5h plus 40 minus 52. We are going to simplify this. I hope you notice the numbers, they add up to 0. 32 minus 20 plus 40 minus 52, 0. So what you have here, 16h minus 5h is 11h plus 2h squared. Take the h out. And remember, when we get 0 over 0, and that's the case here, the problem is the 0 in the denominator. You're hoping to get rid of it. It does happen. Now, if you replace the h with 0, you get 11 feet per second. As far as the units are concerned, are the same units. This is delta S over delta T. This is ds over dt. So in both cases, ultimately, it's a change. Either average change, average rate of change, or instantaneous rate of change. All right, so we want to find this equation, and we need to know that a is 16 and f of x squared of x. So we are going to need two things. We need a pair which is given and the slope which we find through one of these formulas. M is equal to limit of f of a plus h minus f of a over h as h approaches 0, and a is 16. F of 16 plus h, plug it into this, and minus f of 16, you can plug it into this or just use 4. On purpose, I want to use square root of 16 just to remind you what you're looking at. If you plug in, of course, you get 0 over 0 indeterminate form. And the technique was to multiply by the conjugate. This is a minus b, the conjugate is a plus b. So I'm reminding you that a minus b, the conjugate is a plus b, which results in a squared minus b squared. And so we're going to multiply by the same thing with the plus sign and divide by it. This expression, class, equals 1, and it's acceptable. So if we multiply this, we get square root of 16 plus h quantity squared minus square root of 16 quantity squared, which is 16 plus h minus 16. We can cancel these two. And the numerator has h, which can be dropped from the top and the bottom. And now this, if I replace the h with 0, square root of 16, this is 4, so is this one. They add up to 8, so the slope is 1 over 8. And now, of course, we are going to use y minus y1 equals m times x minus x of 1, which means y minus 4 equals 1 over 8 x minus 16. We are going to distribute the 1 over 8. And then we are going to move the negative 4. And this is the equation of a tangent line. Now, you can sort of check it. If you plug in 16, you get 4. That means this process from here on, this was right. It doesn't say that anything about the slope, whether the slope is correct or incorrect, okay? We are done with this question, but I like to do the second method for practice. So I'm going to use f prime of a equals limit of f of x minus f of a over x minus a as x approaches a. And of course, a is 16, everybody. So we want f prime of 16. So we're going to look at this method also. So f of x, we replace it with square root of 16. F of 16, we replace it with 4. Again, a situation similar to this. You are dealing with the square root. So you have to multiply by the conjugate of this guy, which is square root of x plus 4, and divide by it. And again, this expression, just like this expression, is 1, so this is acceptable. When you multiply these two, you get square root of x quantity squared, so the product here becomes square root of x quantity squared minus 4 squared, which makes it x minus 16 in the numerator. These two cancel each other. And now, if you plug in 16 here, you get 4 and 4, 8, and you get the same value that was found here. Two different ways for practice, everybody. Two different ways for practice. The height in inches of a sunflower X weeks after being planted can be approximated by the function f of x equals 6x minus 1/4 x squared. How tall is the sunflower 8 weeks after planting? And by the way, it says include proper units. You should always include proper units. So can anybody tell me what they're asking us to do here? What do you think we should do? This is the height in general. After 8 weeks, replace the x with 8. So they're asking for f of 8. And so for the 8 minus 1/4 of 64 minus 16, 32 inches. So always report with proper units. Find the average rate of growth from the end of week 6 to the end of week 12, which means 2 points in time is given. Even if they don't mention average, that's the meaning of it. Therefore, we are interested in finding delta y over delta x, which is f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. And that makes it f of 12 minus f of 6 over 12 minus 6. So plug in 12. 6 times 12 minus 1/4 times 12x squared minus plug in 6, 6 times 6 minus 1/4 of 6 squared. And we have to simplify this. Of course, 6 times 12 is 72. This is 144. 1/4 of it is 36, so 72 minus 36. 6 times 6 or 6 squared is 36. So we have 36 minus 1/4 of it, that makes it minus 9. And if we want to put this together in the following manner instead, if we just write here 72 minus 36, and then minus 36 and plus 9, we get 9 over 6, which is 3/2 inches per week. As far as the units are concerned, the units of the numerator change in the function, change in height over the units of the denominator, change in x's, change in weeks. So 3/2 of an inch per week. Okay, so that's extremely important, everybody. Proper units. Now let's go do some calculus. It says find the instantaneous rate of growth 10 weeks after planting. And in this case, even if they don't mention instantaneous, it means instantaneous because 1 point in time is given. So we're going to use one of those formulas. So we're going to use f prime of a is limit of f of x minus f of a over x minus a as x approaches a. And in this case, 10 weeks, f prime of 10 is limit of f of x minus f of 10 over x minus 10 as x approaches 10. So we write f of x here, and f of 10 we plug in 6 times 10 minus 1/4 10 squared. So ultimately, all we have to do is simplify the numerator, everybody. Let's do that. 60. This is 100. So 1/4 of 100 is 25. So we have 60 minus 25. And therefore we have 35 here. Now, before we move on, I notice 1/4 here, or negative 1/4. That's a fraction within a fraction, makes this a complex fraction. And we can get rid of it by multiplying the top and the bottom by LCD, which is 4. So the bottom, nothing happens. You write it as a product of these two. And the top, this is 24x. This one makes it minus x squared, minus this one makes it minus 140. Now again, I'm just concerned with the numerator. I'm just writing to the denominator. In order to factor this, I'm going to put this in descending order, which means minus x squared comes first. Again, to continue with the factoring, I'm going to factor out the negative. As you recall, when we want to factor something where a is positive is easier. So ax squared plus bx plus c. So we take the negative out, it becomes minus x squared minus 24x plus 140. Now you want two numbers, the product is 140, the sum is negative 24. And before we move on, remember x is approaching 10. You have a factor of x minus 10, which makes the denominator 0. The result is 0 over 0. It's the 0 in the denominator, which is bad. We want to get rid of. So we are hoping this has a factor of x minus 10, and it does. The numbers are 10 and 14. Because this is negative, both of them negative. And don't forget, we had a negative sign here. We're not going to forget about that. We're not going to forget about that. If you put 10, 10 minus 14 minus 4 over 4 is negative 1. This makes it positive 1. Same units, inches per week, because units of the numerator over the units of the denominator. Change in height over change in time or weeks. Explain the meaning of your answer to part C. On week 10 or after week 10, the sunflower is growing at the rate of 1 inch per week. So in short, it means increasing, because this is positive. If it was negative, we would say decreasing. Suppose, example 7, suppose that a ball is dropped from the upper observation deck of the CN Tower 450 meters above the ground, and S is f of t, or 4.9 t squared. What is the velocity of the ball after 5 seconds? How fast, or what is the velocity of the ball traveling when it hits the ground? Well, what are we looking for? We are finding the instantaneous velocity at t equals 5, and at t that we have to figure out what's going on here. If I go with this formula and I change the a to 5 for part A, I can finish the job and get the answer for that. Except if I want to go for part B, I got to do the same thing. I got to change the a to whatever number I need and go through the process again. Instead, I'm going to keep it at A. We are moving towards the next section in essence. So instead of V of 5, I'm finding V of A, or V of even T in general. So later on, instead of F prime of A, we look at F prime of X. So we are not going to change the A. I'm going to keep it as A. So it will generalize it at any T equals A. So what is F of A plus H? It's 4.9 times A plus H squared, minus what is F of A? 4.9 A squared. And this you have seen it many times before. This is A squared plus 2AH plus H squared. And I take the 4.9 out of for this one as well as this one. So it gives us a chance to get rid of A squared and minus A squared. So we get the limit of 4.9 times 2ah plus h squared over h as h approaches 0. And this parentheses, we have a common factor of h. We take out the h. And now if I plug in 0 instead of h, I get 4.9 times 2a or 9.8. What does it mean? After a seconds, the velocity is 9.8 times a. So after 5 seconds, replace a with 5. Their product is 49 meters per second. 49 meters per second. How fast is the ball traveling when it hits the ground? Well, when it hits the ground, this function, this distance function covers 450 meters. So we set it equal to 450. Divide both sides by 4.9. T squared is 91.837. And t is the square root of this number plus minus, and we're going to keep the plus only. So t becomes 9.6 seconds. So going back to this, 9.8a for 5 was 9.8 times 5. For 9.6 would be 9.8 times 9.6, which results in the velocity when it hits the ground to be 94.08 meters per second. Meters per second.